Collisions. What are collisions? Explain the possible types of collisions. Develop the theory of one-dimensional elastic collision. Derive expression for final velocities of the two bodies which undergo one-dimensional elastic collision. This is very, very important, not only for intermediate and also for competitive examinations. It is very, very important for other competitive examinations. So what is collision? What is a collision? A process in which the motion of a system of particles changes, but keeping the total momentum conserved is called a collision. So collision means a process in which the motion of system of particles changes, but keeping the total momentum conserved is called a collision. So that is about the definition of a collision. During the collision, there will be exchange of momentum between the bodies. However, the kinetic energy of the bodies may remain constant or it may change. Accordingly, the collisions are classified into two types. So, if there is a change of kinetic energy or if the kinetic energy remains the same, on that basis, collisions are made into two types. So, collisions, the first one, elastic collision. The example is the collision between nuclei and fundamental particles are examples of elastic collision. In elastic collisions, examples are nothing but the collisions which are happening in daily life. What we are seeing in the daily life are examples of inelastic collisions. The collision between a bullet and its target, when the bullet remains embedded in the target, is an example of perfectly inelastic collision. So the bullet is what is called entered into the target and embedded in that is an example of perfectly inelastic collision. What are elastic collisions? The elastic collisions will obey law of conservation of momentum, law of conservation of kinetic energy, law of conservation of total energy. All these three are conserved, and that type of collision where all this momentum, kinetic energy, total energy are conserved is belonging to a category of elastic collision. Generally, we won't see with the naked eye this type of collisions. Mostly it is a nuclear reactions. See, the molecules are randomly moving in a gaseous state. They are colliding elastically. And this type of collisions are called elastic collisions. Here, the best example for elastic collision is nothing but the nuclear fission. That is, a neutron is hitting a boron nucleus. And now it is splitting into two lighter molecules. And that is nothing but elastic collision. So, these nuclear reactions or nuclear collisions are just examples of elastic collisions. Now we see here a collision almost like elastic. The ball is hitting and all these are moving in a different directions. This is an example of elastic collision. So this is also another example of elastic collision. Here you see these spheres are hitting the other spheres which are at rest. This is an example of elastic collision. We are discussing about inelastic collisions. The collisions which we observe in the daily life are examples of inelastic collision, where it obeys law of conservation of momentum, law of conservation of total energy, but it does not obey conservation of kinetic energy. Such collisions are called inelastic collisions. So, what is not conserved in this one? The kinetic energy is not conserved. That is converted into different forms. Sometimes sound energy, light energy, heat energy. That is, the kinetic energy is converted to different forms, and that is an example of inelastic collisions. You see here the collisions between the two cars. The collisions which we are seeing in the daily life are all examples of this inelastic collision. A cyclist suddenly hitting a wall, and that is an inelastic collision. So the collisions which we see in daily life are examples of inelastic collisions. Now we are going to have that derivation part of it. What are collisions? Explain the possible types of collisions. Develop the theory of one-dimensional elastic collision. Prove the relative velocity of approach before collision is equal to relative velocity of separation after collision in the case of one-dimensional elastic collision. It is a very, very good concept. That is, the relative velocity before collision is equal to the relative velocity after collision in the case of elastic collision. That also we are going to prove it. Now, what are the description for this? Let the two bodies of masses m1 and m2 are moving with initial velocities u1 and u2 along the same straight line and collided elastically. After collision, they are moving the same straight line with their final velocities v1 and v2. Now the derivation part of it. According to law of conservation of linear momentum, the total momentum before impact is equal to total momentum after impact. That is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now we bring all m1s one side, m2 other side. Then we get equation 1, that is m1 into u1 minus v1 is equal to m2 into v2 minus u2. It is equation 1. So this equation we got it by law of conservation of linear momentum. All types of collisions obey this first concept, that is linear momentum is always conserved. Now, if it is an elastic collision, then they obey law of conservation of kinetic energy. What is that? The total kinetic energy before collision is equal to the total kinetic energy after collision. So that is half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. We can cancel half on all the sides, both sides, and bringing m1's one side, m2 other side. Similarly, m1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square, equation number 2. Now we divide equation 2 by equation 1. In the equation 2, you see e1 square minus v1 square can be written as a plus b into a minus b. That is, a minus b will be cancelled, a plus b will be left over. That is, u1 plus v1 is equal to v2 plus u2 left over. If you rearrange that one, u1's one side and v2's other side, u1 minus u2 is equal to v2 minus v1. So that is nothing but the relative velocity before collision is equal to relative velocity after collision. Sometimes in the examination they ask only up to this. So after writing this one, you ought to have to write the relative velocity before collision is equal to relative velocity after collision in the case of elastic collisions. So we are going to write u1 minus u2 is equal to v2 minus v1, equation number 3. That is, in the case of elastic collisions, relative velocity of approach of the two bodies before collision is equal to relative velocity of separation after collision. Very important equation for doing the problems. The final velocities of two bodies after collision, after elastic collision, we want to find out. So that is, I want to find v1. So to find v1, what you have to write? Right, v2 is equal to, from the equation 3, v2 is equal to u1 minus u2 plus v1. So from equation 3, I am writing what is v2. What is v2? u1 minus u2 plus v1. Write this equation in the equation 1, that is in the above equation. If you simplify all the equations, so if you are simplifying, replacing v2 in the above equation 1, after simplification, we arrive the formula for v1. What is that? m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2. Similarly, if you replace v1 in the equation 1, we get the formula for v2. What is that? 2m1 u1 by m1 plus m2 plus m2 minus m1 by m1 plus m2 into u2. Like that, we derived the final velocities of the two bodies after elastic collision. Very important formula. You see the similarities in the how to remember it? The denominators are same, m1 plus m2. And the first term u1 and second term u2. Just remaining, you have to remember it very clearly, and this is a way you have to remember these equations for v1, v2.